Water is a very unique molecule. It is the basis for life. All living things have a high percentage of water in their bodies. Jellyfish can be up to 98% water. The human body has like 75% water. So water is the basis for life, and it is a very, very unique molecule. Let's look at the structure of a water molecule so that you know what makes it unique and why it behaves the way that it behaves. So water is a molecule. It's not an element. It is made out of two elements, hydrogen and oxygen. And water is H2O, so that means that you have two hydrogens and one oxygen that make up the water molecule. And water is the only known substance on Earth that exists in all three states at the same time on Earth. So you've got your solid, liquid, and gas. And solid water we call ice. Liquid water is water. And gas is the water vapor that you can see in the air in the form of like clouds. So water is H2O. We've got two hydrogens, one oxygen, which you can see in the picture on your screen. So oxygen is a much larger atom than the two hydrogens, and they are bonded through what we call a covalent bond, meaning that the oxygen and the hydrogen share their valence electrons. So the hydrogen and the oxygens will share valence electrons, and that bonds the two atoms together. And so the oxygen in this picture will be sharing its valence electrons with two hydrogen atoms. If you remember from chemistry, we have a thing called electronegativity in chemistry. And electronegativity is the attraction of certain kinds of elements for electrons. So certain kinds of elements are more electronegative than others, and if they are more electronegative, they have a stronger affinity or a stronger attraction for electrons. In water, water is actually has oxygen in it, and oxygen has a high electronegativity, or a higher electronegativity than the hydrogens. Because of this, you have the electrons from the hydrogen that tend to spend more of their time around the oxygen atom, because the oxygen atom is more electronegative. So because the electrons from the hydrogen spend more time around the oxygen, and electrons have a negative charge, the oxygen side of the water molecule is said to have a partial negative charge. So we can write that, you'll see it with like this little lowercase like delta sign and then a minus after it. So it's got a partial negative charge because the electrons from the hydrogen spend most of their time around the oxygen. And so because of the negative charge of electrons, the oxygen has a slightly negative side. If you also remember from chemistry, hydrogen have one proton and one electron. There's the smallest atoms. And so because the hydrogens are giving up, for the most part, their electrons to the oxygen, what you have left for the hydrogens are the protons. And protons have a positive charge, if you remember, from chemistry as well. And because they have that that positive charge, the hydrogen side of an water molecule actually has a partial positive charge. So it's got a partially positive charge. Because water has a charge across the molecule, so it's got one side that's partially negative and one side that's partially positive, we say that it is a polar molecule, or it has two poles, two sides that have different charges. So water has one side that's negatively charged, one side that's positively charged. Let's look at how that actually affects water and the interaction of water molecules together. So water molecules, because they have this partial positive and partial negative sides to them, water molecules are attracted to each other. So that partial negative side of the water molecule, the oxygen side, is slightly attracted to the positive side of the water molecule. Because if you remember, opposites attract, right? So positive and negative charges attract. So those positive and negative charges on other water molecules will be attracted to each other. That weak attraction is called a hydrogen bond. And that hydrogen bond is actually going to affect all of the properties of water that we are going to see.